Hello, this is Sarah Perez, and I'm going to be sharing with you a little bit about how β-Hydroxy-β-methylbutyrate, also known as HMB, prevents muscle wasting. First, I'm going to lay down a little foundation for us to start from. Many early studies provided the evidence that leucine has strong anti-catabolic effects in skeletal muscle. These results, at least in part, reflect the effects of its metabolites. This is a simplified diagram of the breakdown of leucine to show the endogenous production of HMB, which is metabolized from alpha KIC by KIC deoxygenase. Note, HMG-CoA is a substrate of HMB production. HMB attenuates muscle loss by the inhibition of protein breakdown. Some studies suggest that this is the most important mechanism of the anti-catabolic effect of HMB, so we'll elaborate on this point more in just a moment. Muscle wasting is also attenuated by stimulation of protein synthesis. This is thought to be through stimulation of the mTOR pathway. HMB is also thought to aid in the stabilization of the sarcolemma. This is through HMB's conversion to HMG-CoA, which enhances the production of cholesterol, which can improve and repair sarcolemma. Of course, more research must be pursued in order to validate these theories in human metabolism. So here we have my depiction of the proposed mechanism in which HMB inhibits the ubiquitin proteasome system. So here we have our sarcomere, our muscle fiber. It's made up of actin and myosin. And here we have our 26S proteasome, which is our ubiquitin proteasome. It's made up of 19S and 20S complexes assembled together to make this proteasome. Here we have a number of enzymes involved in breaking down these protein complexes and attaching ubiquitin to them. Once we get a chain of ubiquitin, it will enter our ubiquitin proteasome and will be broken down into peptides and polypeptides. It is thought that HMB reduces the protein expression of the subunits in these individual complexes, and this ubiquitin proteasome fails to be assembled, preventing the breakdown of protein. So why are the roles of HMB significant? Muscle wasting is a prominent issue faced in the medical field. In fact, ICU patients tend to lose about 2% of their muscle mass per day. Some may lose up to 50% of their total muscle mass during their stay in ICU. Patients with corticosteroid-inducing muscle wasting may greatly benefit from HMB supplementation. In fact, the nutritional supplement Ensure is marketed for containing HMB. Benefits from HMB supplementation have been seen in clinical conditions such as cancer cachexia, AIDS, sepsis, endotoxemia, as well as in aging. Athletes have also been found to be aided in taking HMB supplementation. Evidence was found that HMB may have an anti-catabolic effect during both normal training and during intensified training in ad-lib caloric intakes and in calorie-restricted conditions. However, HMB may work in more stressful situations better than in less stressful situations. Due to HMB's anti-catabolic effects, it can also attenuate the loss of muscle mass and strength caused by intensive exercise during periods of caloric restriction and give athletes the ability to gain strength faster than if not taking HMB supplementation. In summary, there are many mechanisms involved in regulating muscle mass. HMB curbs the effects of corticosteroids in ways such as decreasing protein breakdown, increasing protein synthesis, and stabilization of the sarcolemma. Leucine has long since been associated with the regulation of muscle loss. Proposed mechanisms, such as the one demonstrated, show how leucine's substrates impact this regulation of skeletal muscle. The ubiquitin proteasome system is responsible for seeking and destroying damaged or faulty protein. Thus, inhibition of this process would help to explain the attenuation of protein degradation seen in those treated with HMB. However, more research must be pursued in order to validate the exact actions of HMB on protein metabolism in humans. Here are my references, and that is all. Thank you.